Hello and welcome. My name is Akhil and I'm going to present our project with help of my teammates. Our project is about for signature forgery detection, which is a topic in the field of artificial intelligence and machine learning. Handwritten signatures are very important for verifying and authenticating different kinds of transactions and documents, such as in banking, legal, and education contexts. However, there are also many cases of signature fraud and forgery that can cause serious problems and losses. That's why we need a reliable way to detect fake signatures from real ones. In the previous attempts to solve these problems used k-means clustering, which give a complex and inaccurate method. We have developed a better solution using convolution neural networks, which are more accurate and simpler to implement. CNN can automatically learn the most relevant features from the data without human intervention. They are very good at identifying categorizing images. CNN use the same weights for the different parts of the image, which is a major benefit. Convolution neural networks also reduce the amount of computation needed compared to a regular neural network. CNNs apply the same knowledge to all locations in the image. So, abstract will be continued with my friend.
Handwritten signatures are important for security because they can be used to authenticate and verify people. However, signatures can vary depending on many factors, such as the strokes, length, continuity, and thickness of the writing. This makes it hard to detect fake signatures. To solve this problem, we can use an image-based system that captures and recognizes signatures. The system extracts various features from the image of the signature, stores them in a database, and then uses convolution neural network (CNN) to compare them with the original signature. We can use different methods for feature extraction, such as grayscale, and binarizations. We need to train the model well to get good results. The key stage is feature extraction, where the CNN algorithm captures the signature features. The better we extract the features, the better we can recognize them. Next, my friend will continue.
The algorithm used in our project, convolutional neural networks, is an extended version of the artificial neural networks, which is predominantly used to extract the features from the grid-like matrix datasets. For example, visual datasets like images and the videos where data patterns play extensive role. CNN architecture and implementation. Here we have the various layers like input layer, convolution layer, pooling layer, and the fully connected layer. In first three layers, we can see here that feature extraction takes place, and the followed by the other layers or classification takes place. This is a brief about the CNN algorithm we'll be using in our module and model. Let us explore our project. Now, this is a project implementation. Right now, I'll be showing the just brief steps involved in our project. First, the model building. Initially, we have built the model using the CNN. This is the key step where we create our model. Next, datasets loading. Well, after creating the model, the datasets are loaded into the training sets used for training. This datasets data.py file used for the loading the data. And the training phase. After loading the datasets, the datasets are loaded into training. The training phases are done here. Is the training phase. The in detail part will be shown in the VS Code. Let us discuss it later. And the pre-processing and the statistics. Like the get data set start will be pre-processing the data and the getting our statistics like the grayscale mean, grayscale standardizations. These are front end files to array conversions. I mean, this is the I'll be explaining this in detail in later. And the main function app.py, this is the main function which will be act as the main. I'll be explaining in detail. And the app.py, this I said that I'll be explaining now. And the front end UI. Front end UI is used for the creating a GUI. We have used the HTML CSS for creating this GUI. And this is the interface we have created using the JavaScript, CSS, and the HTML. Yeah, let us explore it in the VS Code. I will be showing the execution and the implementation using the VS Code. This is our project, implementation of our project. Okay, as I mentioned earlier that we have the several modules which we have divided into, and coming to our first one, model.py. Yeah, model.py, as I said that model.py will be creating the model using the CNN. As I mentioned earlier that we are using the various layers in this, like convod. Here convod is nothing but the convolution layer, and the max pool is nothing but max pooling layer. RLU is the activation function, and the other layers, flatten layer and linear. These are the layers used in a CNN. So this module will be help us to create the model, this entire module. Next, coming to our train model, train.py. Train.py, as I said that it is used for the training the data, and we have just loaded for any training data. We should have the data sets. So data sets are loaded from the get data stats. Sorry, data.py. Data.py will be loading all our data from the data sets, and these are implemented and extracted. Here we can see that various modules like torch, matplotlib. These are used in our project. Yeah, here we can see that net is equals to network. This is the class which is used in the model creation, like model.py. There the model is created in that. We have just extracted the network here. Like net is equals network will be implementing our training data sets. You can see that various torch.optimizers, optimizers, the approaches used here, and the filters we have used here. We can see in our code, and later accuracy. Yeah, we can print this will print our accuracy graph, and this is the our training one. Yeah, this is the training phase as I mentioned previously. Yeah, coming to our next one, util.py. As I said that I have shown you that the GUI where it contains the two chosen folders. Like one is a faked one is the for real original one. Uh, the backend procedure will be done using the util.py. Next, as I told this about the data.py is completed and the app.py. Yeah, app.py is the main one where we are importing all the all the modules which we have created previously, like model.py, train.py, util.py. These are imported in this using this. So you can see the command like from model import network. It means that we are just importing the model we have created using the model.py. Okay. Next, model.py. Yeah, this is we can see here, and this is a full procedure. I will be explaining the key feature for here. Here you can see that original is equals to request.file dot original. I mean, it means that it will be scanning the original image what we have imported. I mean, what we have extended the in the import file. That will be scanning through this process. We can see here that process.pil original. This means that when the image is uploaded in that, the raw data will be getting into the original one. While similarly to the fake is equal to process pil and the fake. This will be also scanning the fake one. This is a fake one. Okay, these two are used. This original and fake will be used for that. Used to store the data from the GUI. Next, here the process is going to done. This is a one main function. Softmax function. This is a very main one which is used for the classification. I mean, it will tell about that whether it is a forged or the genuine. This is a main function which where the output will be 0 or 1 like that, like get probabilities. This is about the main app.py, which is the main function which we have imported all the modules in this, and we can see that various imported modules, and we all know about the matplot library and the tiras and pandas we have used here. These are the main one. Okay, now let me explain the implementation of our code. I mean implementation of a project. Yeah, in my folder I just imported all the files from VS Code here. I saved here. We can see that app, util, train, model, data, get data stats. These are the total modules we have seen in the VS Code. Okay, now let us implement it. So first, in order to implement that our GUI, our project, you just type the CMD. Just control E and type the CMD. Yeah, we will be getting the pop-up window. Now just type the Python app.py, because we are just using the app.py as a main one, so that we are running the app.py as a main one. Okay, let us see this, we will be getting one type of HTTP link. Just wait for it. We will be getting here. Yeah, we can see here that we got the some HTTP link. Yeah, this is the link for our website what we have created previously. Let us copy it and go to the browser like Google. Okay. Yeah, this is our GUI. Now let us implement our project whether our model is working or not. Okay. First the original image. Yeah, choose one type of original image like I just saved it as original and the faked one. Faked one like the, yeah, fake. Yeah, because these both are original and fake, the output should be like a forgery one. Let us check it now. Yeah, we can see it here that forged accuracy score is a 0.92 and the confidence level is a 99.9%. This is for the forged one. Okay, let us check for the whether the image is same or not. Let's check it. This is one the this one is the original one. This is also original one. Let us check it. Yeah, this is same because they both are signed by same person. So we got the same with the accuracy score of 0.92 and the confidence level of 100%. This gives us the project overview and implementation. Coming, let us back to your PPT. Yeah, as I said earlier, that these are the all the process phases. You are just go through your project and the main function I explained it and the GUI interface I just said about this and the output I just explained it. Okay, this is our implementation of project. Next, the next content will be followed by my friends.
In conclusion and future scope of a project is signature forgery detection is essential for maintaining the security and authenticity of signatures. By using modern technologies like convolution neural networks and feature extraction methods, we can precisely examine and compare signatures to see if they are real or fake. This process involves finding important features and patterns from signatures and training a system to recognize and distinguish between authentic and forged signatures. In conclusion, although signature forgery detection has made significant advantages, there are still areas for innovation and improvement. By working on improvement feature extraction, enabling instant detection using multimodal analysis, and exploring deep learning approaches, we can increase the efficiency and accuracy of signature forgery detection systems. Thank you.
Thank you.